Okay, today we're going to be briefly talking about extensions of FTC, and FTC stands for, yes,
Fundamental Theorem of Calculus.
Fundamental Theorem of Calculus, thank you.
Fundamental.
Which is really the biggest thing. So this is related to note card 46, and so what this does is it sort of gives you a sort of practical applications. It's really kind of organizationally the same as note card 46, but just tells you practical uses of that. And so basically it talks about the integral of, to eliminate the rate you need to integrate, right? So so here you have this, you're going to talk about amount. So you have a flow rate of something. The integral of the rates are going to be amounts. And then you're going to have a starting value out here, and you can have a terminal value, and then they give a little hint of a type of problem. But otherwise it's really the same as note card 46. So let's go look at this one right here. Okay, if the integral from -2 to 2 of x squared plus k dx equals 16, then k equals what? I'll give you a hint. There's one thing about if you understand what the graph of that function looks like, this makes of this a pretty easy problem. Any ideas on this one? Okay, what is the integral of this? What is this equal to right here?
Oh, I'm nuts. I'm sorry. My thing's just goofed up. Okay, that would be.
You should be able to, well, I'm looking for somebody to tell me kind of more or less instantly what its integral is right here. From your understanding of what this function looks like here.
How would it be?
This is going to be 0. All right? So since we know the integral of this element of it is 0, and why do we know that?
Because like some of it's negatives.
The reason we know this is because here is the graph of x to the 7th power right here. It's this thing right here. And so what you're going to have is at +2 - 2, you're going to have this area cancel out this area. So the integral of this thing right here is 0. So that means what? So now you know that. All right? So what is k going to be? What is k going to have to be here? Let's look. You go from -2 to 2, right?
Okay.
And you have an area of a rectangle that is 16. What is k going to be?
4. That's crazy.
So we have is y is equal to 4 is the way you make this happen. Which is going to be k is equal to 4. So that's going to be it. So you have 4. If you substitute in 4 for k, you're going to end up with the area of 16. And you can work this out as more formally. I mean, graphically like that is the way to do that. But you can work this out more formally, that you could say, okay, then kx from -2 to 2 is equal to 16, right? And so you can just substitute in for -2, so you have 2k times 2, right? No, wait a second. Okay, you replace x with 2. That's going to be, yeah, 2k minus -2k is equal to 16. So you got 4k is equal to 16. So you could work it out more formally that way. To me, the easier way to look at it is just the graph of the thing, because that just makes your life easier, I think. And let's see if we can look at one more here today.
Oh, I think it's time to go.
Short class today.
That's all right.
Big class today.
This
It's
one
a
here.
productive class.
That was okay. This one here. Yeah, we'll look at this one here. Okay, you got this one here. A metal wire of length 8 centimeters here at one end. The table gives selected values in degrees centigrade. Find the integral from 0 to 8 of t prime x dx, indicate units of measure. So what is that going to be? Here's the temperature, and here's the distance from that, and so what is this going to integral from 0 to 8? What does that represent? You ever done that? You ever touched something that's hot, that's metal, and closer to the source, and then it gets hotter and hotter, and then cooler farther away? That's what this is. It's a wire. So what's happening to the temperature the farther away it gets from x equals 0?
Going lower.
Going lower, right? So your amount is what? The what? Amount is what? Amount is what? So T prime, that's your rate. And what is amount? What is the temperature itself going to be?
T.
It's going to be T. And so what is your answer from 0 to 8?
55 minus 1.
It's going to be this right here. It's going to be 55. Because that's going to be the accumulated decrease in temperature all to there. And so where you end up is amount. So this is the amount, is the integral of rate. And so this tells you what that exactly is. So your answer is going to be 55. So this thing right here equals 55 degrees, and that's degree C. And explain the meaning in terms of temperature of the wire. How do you explain that? How do you explain that? We talked about P-vang, right? How do you explain this? What's the physical thing that happens? How about the temperature is 100 degrees right at 0 and gets less and less and less till at 8 centimeters away, I guess, then that's 55 degrees. That's it.